Alright, welcome back everybody. I got another lecture here for you. In this video we are going to check out some really cool Vellum stuff. Vellum is a very interesting part of Houdini. Allows you to simulate cloth and many other types of objects. You can even tear the cloth apart. You can simulate ropes and strings. If you've never used Vellum, that's alright. I'm going to show you step by step how to do a really cool trick here. And if you're interested in seeing more about Vellum, I have a 8-part series available over there on my Ko-Fi page. You can check it out through the link below. Remember, the Ko-Fi subscriptions are different than the YouTube subscriptions. You do have to pay for that, but it's as little as $3 a month. Works out to be about 10 cents a day, so it's not too much. Now in this lecture, I'm going to show you how we can actually inflate Vellum, so we can make an inflatable object here. It's pretty cool, and it's actually very simple. Vellum is surprisingly easy to use. It's much simpler nowadays to create something like a cloth simulation than how it was many years ago. So if you want to follow along, open up a session of Houdini and just hit tab and type Geo, and we're going to dive in, and let's just create a box. We're going to inflate this. We can think of this as maybe like a couch cushion or something, you know, a pillow. Let's change its size and the y-axis to 0.2. We'll squash it down. Looks more believable then. Let's also, while we're at it, let's just drop down a grid. Visualize it in a template mode here. And let's drop that down in its center to -0.1. That'll seat it at the bottom there of that box. We can use that as a ground plane. Now let's drop down a remesh node. So hit tab and start typing in remesh and it'll pop up. Wire into that first input. Let's visualize it here. You can see what it does. It's going to basically triangulate the geometry, and it's a good idea to remesh your geometry if you can when you're going to pipe it into a Vellum solver. I've read in other areas in the Houdini documentation that this just optimizes the topology, and it should make that Vellum solver behave more stable and faster. So let's go up here and let's see here. This target size, if you reduce this, you're going to see a lot more triangles pop up. So let's put this down to something like, I don't know, 0.026. That shouldn't be too dense here. You can see it gives us a lot of faces here. This is actually very critical to do if you want to tear this Vellum apart that we're going to create. We're not going to do that in this lecture. I'll show you that later on. But you're going to want to have a lot of faces to be able to tear along edges, and this remesh node is a very simple way of getting those faces. So now we can just drop down some Vellum. Let's do Vellum, and there should be a balloon. Here we go, a configure balloon. And just plug this remesh into the first input. Also hit tab and type Vellum solver. You need to wire in a solver. And now we can also plug our grid into this third input here. You can see it says collision geometry. Now let's just see what we get by default. It's not going to be too impressive, but we want to always see where we're starting at. We might even have to move the ground plane. Yeah, see how it kind of falls through. It's because it's right on the same plane there. So just add a little bit of an offset here. We can do, maybe let's do -0.105. That might be enough. Yeah, okay. So now we got a nice ground here. And our little couch cushion just collapses. We can go in and make some adjustments to that if we want to. Let's just check out what we get by default with our cloth here. Let's see, we can do... Let's increase this to say like 20. And let's replay it and just see what we get. It's still collapsing quite a bit. That's all right. Let's go to our pressure and increase its stiffness. Let's go to 25. And again, replay it. You're going to want to replay pretty much every time you make these changes. You can see now it retains a little bit more of its shape, but that's really not the point of this. We want to inflate this geometry. So let's see how we can do that. Now, typically what you do is you adjust this rest length scale of your pressure. So let's just increase that to something like 15. And now hit play and see what happens. And boom, look at that. You get a extremely inflated geometry here. Our couch cushion now blew up here, and really cool. Very easy to do. But now let's say you want to do this animated. You don't want it to just do that right from the beginning. So you could go here and, like usual, you would animate this stuff. So let's see what happens. Let's disable our auto update so it won't try to sim. We'll go to frame 10. Now you can hit Alt and left click this rest length scale. Now go to frame 20 and just put it up to even like 12. That's plenty. Alt and left click, rewind. And now we can re-enable this. And now let's hit play. And you'll see it doesn't do anything. Okay, so the default nature of this Vellum is it only looks at these values on the first frame. Doesn't matter what you set them to. If you animate them, it's not going to pick that up by default. So it's very simple to actually work around that. We can right click and let's say delete channels. I find it kind of ironic that they have now tried to put all these geometry SOP level dynamics nodes so that you can work with dynamics at this level and not have to dive in yet to do just about anything even remotely intermediate or advanced. You still have to dive in. So on your Vellum solver, just double click it and you'll see we get this kind of intermediate state. We're in dynamics, but we're not really in the Vellum solver. We're buried in it. A few layers here. You can see we're inside some other nodes, but this is where they have it set up for you to do some easy control. So you can hit tab and type Vellum constraint properties, plug it into our source. Now, if you've ever tried to set this up on your own, you may have gone online and searched around, and people will tell you that, oh, all you got to do is go in here and you can then animate these values. So let's try it. Let's go to this rest length scale, and we can disable our auto update again. Go to frame 10, Alt and left click, go to frame 20, set it to 12, Alt and left click, rewind, and now re-enable. Let's also go back up here to this geo level and pin this view. We want to make sure we're pinned here so that when we're in here, we're going to see the correct updated data. Now just hit play. Now look what happens. It's kind of expanding, but it looks horrible. It doesn't look like anything like we expect. All right, and there's a reason. There's always a reason in Houdini. What many resources don't mention when you search how to do animated Vellum pressure setups like this to expand an object is they don't tell you that by default this Vellum constraint property is not going to work directly on the constraint node that is the pressure constraint. It's doing it here on the cloth, so it's changing the wrong value for us. It's animating this one. We want to animate this one, and it's very simple to actually do that. All you got to do is enable this output group, and instead of just leaving it the default stretch, just call it like pressure underscore stretch. That way we know it's definitely the pressure constraint when we go back into our Vellum solver here. So dive back in. Now you just go up here and enable this group, and in our drop down, well, you have to actually rewind. See, we're on frame 4, so it's still using the solver state from our previous sim. So if we go back to 1, now we will have our pressure stretch. And if we just hit play, we'll get our expected result. There we go. It works very nicely now. Very fast and simple to do. So just keep in mind, when you drop one of these Vellum constraint properties, by default, it's really only going to be working on the main original cloth constraint. It doesn't automatically know which constraint you want to work on. You'll even see there are some other groups here that you could isolate to, but we wanted our pressure stretch, so we had to create it. And they make it very easy to do that. You just have to enable the output group on the constraint that you want to have access to. So let's see though. This kind of is cool, but animating things in here in the .NET, we typically don't really want to do that. We want to do it back up at geometry level. So let's actually right click and delete. Now we'll be back to our default sim here where it just squishes down and does nothing. But let's go up here and I'll show you how to work this a little bit up here at the SOP level. We could drop down a wrangle, just do an attribute wrangle. And we're going to just replicate what we've already done. So it's going to look the same in the end result, but I'm just going to show you a different way of doing it, and that opens up the door for a lot of other things here. So we could say run over points. We don't really want that. We don't even need it to run over primitives. We can just run it over detail, because really this pressure value is going to run on the entire pressure constraint. It's not like you can enable some of it. You know, imagine if you tried to do like a split where you wanted this half of the box to have a higher pressure and this one to have a lower pressure. It's not going to behave the way you would think. This is just one volume, so we can't really tell it only inflate the right side but not the left side. So I'll show you actually how to do that with a different trick later on, but for now let's just work on a consistent pressure animation for the entire system here. And we're just going to do, let's see, let's just call this anim, and we will equal it to smooth. And if you've never seen this before, that means you should watch my previous lectures. Okay, it's discussed already, but I'll give you a brief overview here. Smooth, as it says, computes an ease in out interpolation between values, and it's going to use value 1, value 2, and then an amount. So if we say we want value 1 to be 10, value 2 will be 20, and the amount we'll use frame. What's that going to do? Well, all frames up to 10 are going to output a value of 0. Once we get to 10, it's going to start smoothly interpolating to a value of 1 once we get to 20, and it's going to use the current frame of the time slider to do that. You can confirm that in your geometry spreadsheet, and this is where you see detail attributes. You can see anim is 0. Let's actually make this time slider a little smaller here so we can get in here a little better. On frame 10, you'll see it's still 0. The moment we go to 11, you'll see it starts to increase, and it's going to keep increasing until we get to frame 20, and on 20 it'll be 1, and that's the maximum, that's the ceiling. It never goes above 1, and it never goes below 0, obviously, which is great, but if you recall, we animated the value to be from 1 to 12, not 0 to 1. So it's very simple to actually change this behavior. Let's just back up. And all you got to use is a fit 01. And you'll see it's going to tell us, takes the value in the range 0 to 1 and shifts it to the corresponding value in a new range. So, new range, we want it to be 1 to 12. And again, geometry spreadsheet is fantastic to review your values to make sure everything's working correctly. Now look at that. Instead of 0, it's 1. And on frame 10, it is still 1. And then what's it going to do? It's going to start increasing until we get to 20, and we'll have that value of 12. So now we've basically recreated our keyframes here in a procedural manner using some code. Now we can go back in, and I just completely screwed something up here. So let's hit undo. My mouse has been freaking out a little bit. I think I need to get a new one. It's registering clicks when I'm not clicking. Anyways, let's get back into this. Let's dive in. Now, you can't just say, oh, okay, I'll just use my anim value. Let's hit play and see what happens. Nothing. It's actually setting this rest length scale to 0, so you see it's like completely deflating, which isn't good. Right-click and delete channels. Keep that at 1. Let's go down here and say use Vexpression. Now, before we dive into this, I'm going to go back up to GeoLevel and just rename this to something like anim. Why not? It'll make it easy to find it. Now let's go back in. And now we can go like so. Now in here, typically we do something like at rest length. Okay, but that's not how you do it when you're in a volume constraint property. You don't need this little at symbol. So you just put the attribute name that you want. So rest length scale, it tells you right here, parameter rest scale. So let's actually change it to rest scale. And we will say equals. Now, we can't access this directly like this. However, this is very similar to our attribute wrangles. We're probably going to get an error when we click off of this because we have incomplete code. Let's see. Oh, no. It doesn't care. That's nice. So go over to your inputs. And now you can pick any of these, like 3 or 4. Just tell 4 we will go to SOP. And now let's go find our anim. Here it is right here. Now we will be able to access this just like we access all this stuff in any regular wrangle, and you should be very familiar with that if you watched my wrangle series. And as we know, indexes start at 0, so it's going to be 0, 1, 2, and 3. So we can go back to our properties, go down here, and we can just say detail, because we're going to grab a detail attribute. And it says reads the value of a detail attribute value from a geometry. We know we want to use 3. And what do we want? We want anim. And that's it. You do not have to put the third value here. It's a null value because there is no point number or prim number. It's just one value. Details just one value. So now we can just hit play and we'll see the exact same behavior as before. So you might be questioning, well, why did we do all that? Well, the reason we did all that is because this opens up the door to be able to do a lot of things up here at this level and then pipe it down in to our Vellum constraint property. Okay, I'm not going to go any beyond this in this simple lecture because this is just an intro, but I will definitely be putting up more lectures on Vellum because it's just so interesting and everybody should be learning these tricks for Vellum. It's such a cool part of Houdini. But, you know, there's more we could do. I'll show you a couple more tricks here. So, like I said, what if we wanted to have only half of this inflate? How could we do that? Well, let's drop down a group node and just wire it in here to our anim. And let's say points. W key will go into wireframe. You can see it selects all the points, but we don't want all of the points. Let's say, all right, base group. Let's say at p.x less than 0. Now look what happened. It automatically just picked all of the points that have an x value lower than 0. So this is the center line of our geometry. This is the origin. X is going, you know, +1 on this side, to -1 on this side. So it just automatically selects all of these points on the left. And let's actually name this left so it's going to be easy to find them. Now let's just plug this output into our Vellum cloth. And let's create a new constraint. So we'll do Vellum constraints and just drag it in here and it'll automatically wire all 3 lines in for you. And let's go up here and pick, let's just try struts. That should do it. And let's do points. This is going to be able to select our left points now. Let's type left. And now let's pick again for our target geometry. We're just going to strut them to themselves. And now stiffness. Let's do 100, but change this. See, it's going to multiply this by this weird number here. Let's just say by 1. So it's just going to be a value of 100. And now let's see what we get. Let's go hit W so we go back into wireframe or out of wireframe and disable our scene grid here. And we'll hit play. Now you see obviously we're constraining this left side, so look at that. That's really cool. We only blow up our right half, which is great. That's kind of interesting and very fun to set up stuff like this, and you can see you can get very, very nice control over your Vellum by using multiple constraints. But now, what if we wanted to have this inflate later on in our sim? Very simple to do. So, go to your struts. Stretch. We know we're going to want to animate this, but we know we can't animate it up here. We know we can do it inside of our solver SOP by way of one of these Vellum constraint properties, but we need an ability to grab that constraint. So, again, output group, enable it, and let's just call this struts underscore stretch. Now we know exactly what it is, and now we can dive in. We can hit tab and type Vellum constraint properties, wire it directly in, go up here, group activate, strut stretch, stiffness. We know it was set to 100. So now if we hit play, it's just going to do the exact same thing. All right. But what we can do is say back it up and say here, let's disable this or put it into manual mode. Alt and left click our stiffness. go to say frame 40 and just bring this down to 1. Alt and left click it. Back up. Let's do our auto update mode, and now we'll just hit play. And we get our cool little constraint here. And then those constraints go away. Or, our stiffness goes to 1, and now the whole thing inflates. Now you see we have crazy fast playback, so let's enable our little clock face. And now you'll see what we get. Very cool and very easy to do when you know how to do it. I'll hit stop here. So that's all I'm going to be really going over in this introduction into this Vellum cloth setup. It's very cool to be able to inflate geometry over time, especially animating it. Once you know how to set up values up here, you could do all different things. You could do grouping. You could do things like using color transfer to trigger things like I've shown in many other examples. You can do whatever you can think of to create this value up here in a wrangle or in any other manner, and then source it down in here through one of our Vellum constraint properties. Just remember, if you want to be able to access additional constraints other than the initial cloth constraint that gets created, you want to make sure that you enable those output groups. That'll give you easy access once you're in here to be able to go and pick whatever you want and then modify them. And then you can also do it, very, very much like a wrangle, where you can tell it what geometry you want to have on an input and then access it down here using a detail wrangle. Or sometimes you're going to need to use point, or sometimes primitive, depending on what kind of data you're trying to access, but it's all very simple. And a lot of times I've searched in the past on Google, and there's questions where people ask, hey, how do I animate the inflation of geometry over time? And the answer is, just drop a Vellum constraint property node. But many times they forget to mention this workaround that you need to do. You need to be able to actually tell it you want to do it on the pressure values here and not just the standard cloth constraint. So we can go back up here. We'll just hit play, and that's that. Very cool, very simple. Remember, if you're interested in Vellum, I have more Vellum. I have 8 more lectures available to my Ko-Fi subscribers. You just head on over there through the link. It starts at $3 a month, and that gives you access to everything I have to offer. All the scene files, extra videos, some extra goodies here and there too. So check it out if you're interested. Remember to like and subscribe this video if you liked what you saw. Subscribe to the channel, that way you'll know when I put the next round of these Vellum related videos online. Also, if we can get plenty of subscribers to this YouTube channel, I'll eventually be able to offer all of this information for 100% free. There won't need to be a separate Ko-Fi subscriber section. But we got to get to at least 1,000 subscribers before YouTube even allows you to try to monetize your channel. So we're on the way, but it's going to take quite a while. With that being said, I hope you enjoyed this video on Vellum. Stay tuned to see a lot more. I'm absolutely going to upload more. Vellum's a lot of fun to work with, and I look forward to making more of these. So have fun with this. You can go over to the Ko-Fi site and grab this scene file for download if you want to check out this example. Always remember, it's a great way to double check your work. If you don't have something working correctly and you think you followed the video perfectly, you could have easily missed something minor, and it's great to have these HIP files to double check your work. And this is a free file. All you got to do is go over to Ko-Fi, because that's where it's hosted and it's free in the shop. Anybody can download it. I'll leave a link directly to the HIP file in the description of this video. And with that being said, this is done, and I will see you in the next one.